Hello everyone, welcome back to Sulekha physics classes. Hope you all are doing good. Today I am going to start one short revision of chapter Human Eye and Colorful World of class 10th. According to revised syllabus, some topics are deleted from this chapter like human eye and structure, power of accommodation, defects of eye, all these topics are deleted. So no need to study these topics from examination point of view. But still there are some other important topics which you have to study in this chapter. So topics to be covered in this chapter are refraction of light through a prism, dispersion of white light by a glass prism, recombination of white light by a glass prism, then rainbow formation, atmospheric refraction, some phenomena based on this atmospheric refraction like twinkling of stars, advanced sunrise and delayed sunset, then scattering of light and some phenomena based on this scattering of light like blue color of sky, color of sun at sunrise or sunset, red color of sunrise, right? Then longitudinal effects. So I will discuss each topic one by one. Okay, so let us start quick revision of this chapter. First topic is refraction through prism. You already know about refraction. We already discussed in chapter light. What is refraction? When light ray travels from one medium to another medium, there is a change in path of light. And why this change or bending of light takes place? Due to change in speed of light from one medium to another medium. So what is refraction? The phenomena of bending of light when light ray travels from one medium to another medium, right? Now another term is prism. What is prism? Prism is actually a transparent material and it is made up of glass and having two triangular bases and three rectangular surface like this one. There is one triangular base like this one, then rectangular surface like this one, okay, and then there is another triangular surface. So prism is something like this one. It has two triangular bases and three rectangular surface. One is this side, another one is backward, and another one is upward. Now light enters through this backward surface of the rectangular, it comes out through this forward surface of rectangular surface, right? But here I am going to draw only this front surface and light enters through this side and comes through this rectangular surface. So this is the front surface of the prism. Light is incident on this surface, then inside the prism refraction takes place due to change in medium and then it comes out through this surface. So here I am going to incident light on this surface. Here PQ is incident light, right? Now at point Q, here this one is air and air is what? Rare medium, right? And this prism is made up of glass and glass having higher refractive index, it is a denser medium. Now when light travels from this rare to denser medium, what happens? Refraction takes place. And when light travels from rare to denser medium, you know bending of light takes place or refraction or light bend towards the normal. So you first draw one normal. This is normal on this surface at point Q. This one is N1. Now instead of going light through this one, it bends towards the normal like this one. So this is the refracted ray QR, right? Now again at point R, what happens? Again medium is changing. Here this one is denser medium and outside is what? Air. Air is a rare medium. So again at point R, refraction takes place when light travels from denser to rare. And at this time, what is the property of light when it travels from denser to rare? It bends away from the normal. So instead of going like this one, this is the normal N2. Instead of going like this one, it bends away from the normal and it comes out through the surface through this path RS. So here RS is what? Emergent beam. So you can write first PQ. PQ is incident ray. Okay. Then QR. QR is refracted ray. Then RS. RS is emergent ray. Okay. Now you know the angle between this incident ray and normal is what? Angle of incidence I. So I is angle of incidence. Now again at this point This R1 or R you can say, this is angle of refraction, angle between normal and this one is refracted ray. So this is angle of refraction, right? And then again this angle between this normal and emergent beam is angle of emergence. So in this way you draw the diagram and write all these terms. What is PQ, QR, RS, angle I, angle R, angle E. There is again these two surfaces are inclined at some angle and this one is called angle of prism. Angle of prism. Now there is one important angle, angle D. What is this D angle? Okay. Light is incident along this direction, PQ. So if there is no prism, it goes like this one. If there is no prism, but due to prism, light changes their path and it comes out of the surface through this direction, RS. So when you extend this RS, it comes at this point, right now. So this is the original direction of light and this one is the final direction of light, emergent ray, and this one is incident ray. So light deviates from its original path. This one is original path, but light comes out through this prism through this path. So there is deviation of path right now, and this angle between incident ray and emergent ray is called angle of deviation. So this term is very important, angle of deviation. Angle D is angle of deviation. It means light deviate from its original path. Original path means incident ray. So angle between this incident ray and final emergent ray is called angle of deviation. You can write in this way, angle formed by emergent ray with the incident ray due to this prism only. If there is no prism, then there is no deviation of light. This angle of deviation is only due to this prism. So angle between emergent ray with the incident ray due to prism is called angle of deviation. And there is one important relation between angle of deviation, angle of prism, angle of incidence and angle of emergence. You must remember this one. Relation is this, angle of deviation equal to angle I plus angle E minus angle A. This one is not given in your NCERT book, but still you remember this formula. Angle of deviation equal to angle of incidence plus angle of emergence minus angle of prism. It means on which factors this angle of deviation depends. How much in which direction light deviates from the original direction, it depends on which factors. This angle of incidence, angle of emergence, angle of prism, and also nature of this material of which it is made up of, right now. So angle of deviation depends on angle of prism, angle of incidence and nature of material. So in this way you explain refraction through prism. You just draw a very neat and clean diagram and define different terms related to this diagram, right? Or write all these terms and then after that you explain angle of deviation. You must write that refraction takes place here 2 points. First is at Q, refraction takes place, and again at R, refraction takes place. So in this way you explain refraction through prism. Hope it's clear to all of you. Please take a screenshot of this one. Then we move to the next topic. Now, next topic is dispersion of white light through a glass prism. You know, when light passes through a glass prism, refraction takes place. But that light has single color, that is monochromatic light. But what happens when white light passes through a glass prism? Suppose ABC is a glass prism and white light is incident on the surface of this prism. You know, white light consists of many colors. So when white light is incident on the surface of glass prism, it is divided into different colors. It splits into different colors, and this process is called dispersion. Dispersion is a splitting of white light into its 7 constituent colors when it passes through a prism. Now, why this splitting takes place? It means dispersion takes place. We discuss later on, but here this process is called dispersion, splitting of white light into its 7 constituent colors, and that 7 colors are nothing but VIVGUR. I have written here VIVGUR, V for violet, indigo, blue, green, yellow, orange and red. These are 7 different colors of which white light is made up of. And this band of 7 colors This band of 7 colors which appear at this side of the prism is called a spectrum. And as this spectrum is visible to our ears, so it is also called visible spectrum, right? Visible spectrum, because we are able to see this spectrum with the help of our eyes. So now why this dispersion takes place? You know, different colors of light have different wavelength and different frequencies, right? From V to R, wavelength increases in disorder. It means violet color has least wavelength and red color has maximum wavelength, right? Violet color has least wavelength and red color has maximum wavelength. And you know, wavelength is C by nu. Wavelength changes, frequency also changes, because speed of light is always constant in air. But you know, when light ray enters in different medium, their speed also changes with the as wavelength of light changes. So wavelength is minimum for violet color, so speed is also minimum for violet color. Violet color has band minimum speed and red color has maximum speed. And you know, refractive index is what? C by V. If velocity changes, then refractive index of light also changes. Light travels with the same speed in air, but when it enters in the medium, different colors have different speed. Violet color has minimum speed and red color has maximum speed. So violet color has minimum speed, it means violet color has maximum refractive index. Refractive index for violet color is greater than refractive index for red color. Now what happens? You know Snell's law, sin I by sin R equal to some constant, and that is refractive index, right now? Okay, so if refractive index changes different for different wavelength, but I is constant, so to keep this refractive index, to keep this ratio constant, if I is constant, N changes, it means R also changes. That's why different colors has different angle of refraction. Here red color has this angle of refraction, violet color has this much angle of refraction. So this is the reason why dispersion takes place, because refractive index for different colors is different, and due to change in refractive index, deviation of different colors of light is also different. Red color deviates least and violet color deviates most. Why? Because violet color has maximum refractive index. And one point you note down, right? Deviation is directly proportional to refractive index. You note this point, okay? Greater the refractive index, greater is the angle of deviation. And here violet color has maximum refractive index. It means violet color deviates most. Violet color deviates most. Violet color deviates most. And red color deviates least. That's why red color is at the top of the visible spectrum and violet color is at the bottom of the visible spectrum. You must write these colors, okay? Red color is at the top of the visible spectrum and violet color is at the bottom of the visible spectrum, because violet color deviates more and red color deviates less. Then one question is there, why red color deviates less and violet color deviates most? Because red color has lesser refractive index than violet color, and if refractive index is less, it deviates less, right? Now, so these are about dispersion of white light. Please take a screenshot. Now next is recombination of white light by a glass prism, or it is also called Newton's experiment. You know, Newton was the first to observe visible spectrum of a light through a glass prism. You know, when white light passes through a glass prism, it is split into its constituent 7 colors, and that band of 7 colors is called a spectrum, and as it is visible to our ears, that's what's called visible spectrum. Now again you put one inverted prism in front of this first prism. What happens? This visible spectrum again recombines to produce white light. It means what? First prism acts as dispersion. Through first prism dispersion, it means splitting of light takes place, and in second inverted prism this visible spectrum recombines again to form white light. Recombination takes place through the second prism. Here also dispersion takes place, but the angular dispersion produced by the first prism is equal opposite to that of this inverted prism. That's why these recombines to produce white light. You think about this now. This first prism is like this one. When you join this with this second inverted prism, it acts like a glass slab, right now. And you know, inside the glass slab, what happens? When light enters through the glass slab, inside the glass slab refraction takes place, and then again it becomes parallel to the incident light. So these two prisms, when joined, it acts like a glass slab. That's why when white light enters the inverted prism, also white light comes out. So this is recombination of white light by a glass prism. Please take a screenshot. After that, we'll discuss about rainbow formation. Now, next is rainbow formation. Actually, rainbow is best example of dispersion of sunlight in nature. What is this rainbow? Rainbow is an arc of 7 colors produced by dispersion of sunlight by raindrops in the sky. What happens during rainy day? There are small raindrops of water droplets are there, and when sunlight passes through that raindrops, dispersion of light takes place. It means splitting of white light takes place and rainbow is formed, right? And in this way, arc of 7 colors are formed in the sky during rainy day, and this is called rainbow. This rainbow is always formed in a direction opposite to that of the sun. If sunlight is coming from this direction, and then rainbow is formed in this direction, right? How this rainbow formation takes place? Each drop acts as a glass prism. During rainy day, each raindrops acts like a glass prism. Suppose there is one raindrop, then this raindrop acts like a glass prism. And you know, when white light enters through a glass prism, what happens? Dispersion takes place. In the same way, when sunlight enters through this raindrop, at this point, refraction takes place and white light is divided into 7 different colors. Red color is at the top and violet color is at the bottom. So at this point, dispersion of light takes place. Then again, when all these colors reaches at this end, what happens? Light is totally reflected again. Here total internal reflection takes place. Total internal reflection. You study total refraction in the higher classes. You just know that total refraction is a phenomena in which light is internally reflected back in the same medium. So second is here total internal reflection takes place. Red color reflects at this point and bottom violet color reflects. So different colors. Here also all 7 colors, here also all 7 colors reaches at this point. Now again at this point, what happens? This one is different medium, outside different medium, refraction takes place. So here again, this point, refraction takes place. So 3 processes. First is dispersion. At this point, total internal reflection. At this point, again refraction takes place, and all these light reaches to the observer's eye, and observer is able to see all these 7 colors here in the form of rainbow. Red color is at the top and violet color is at the bottom. In this way, rainbow is formed in the sky, right? So you can write in this way, each drop acts as a glass prism. When raindrop refract first, what happens? When sunlight enters here, this raindrop refracts this light and disperses into 7 different colors. Disperse the incident sunlight, then reflect it internally. It is written in the NCERT book, this language. Then again reflection takes place at this point. Reflect it internally. This is called total internal reflection. And again then refract it again when it comes out of the raindrop. And again here refraction takes place. So there are 3 processes. First is dispersion, then total internal reflection, and then refraction, and at last it reaches to the observer's eye. Red color appears on the top of the rainbow and violet color appears at the bottom of the rainbow, and rainbow is always formed in a direction opposite to that of the sun, right? This point is also very important. Light is coming in this way. Here dispersion takes place, refraction takes place, refraction takes place, and then it reaches to the observer's eye. So observer human is able to observe rainbow here in the sky, right, in a direction opposite to that of the sunlight. In this way rainbow is formed. Here 3 process takes place. You must remember these 3 process. Raindrops acts like a glass prism, and you know what happened inside the glass prism. Refraction, first here light dispersion takes place, then total internal reflection, then again refraction takes place, and human is able to see this rainbow. Okay, please take a screenshot of this one. Now atmospheric refraction. What is atmospheric refraction? Refraction, you know, bending of light when it travels from one medium to another medium. This is called refraction. Then what is atmospheric refraction? Atmospheric refraction means bending of light when it travels through different layers of the atmosphere. This is called atmospheric refraction. Here refraction takes place due to different layers of the atmosphere. When light enters through different layers of the atmosphere, refraction takes place. So the refraction of light caused by Earth's atmosphere is called atmospheric refraction. But why this atmospheric refraction takes place? Why bending of light takes place when it travels through the atmosphere? You know, atmosphere is not uniform throughout. Like Earth's atmosphere is not uniform throughout. Its density changes as you move up or down through the different layers of the atmosphere. And due to change in density in different layers of the atmosphere, what happened? Its refractive index also changes. Top layer of the atmosphere acts as rare medium, and bottom layer of the atmosphere acts as denser medium. It means when you move down, right, its refractive index increases, so lower part of the atmosphere acts as a denser medium and upper part of the atmosphere acts as rare medium. Now it's easily you can observe that when light ray enters, suppose this is the position of object. So you know this one is vacuum. Vacuum is free space. In free space light travels with the speed of light. There is no change in medium. So light from this object travels in this way, right now, but when it reaches the Earth's atmosphere, these are different layers of Earth's atmosphere. This one is Earth. Above this Earth, atmosphere is there. So when light ray reaches at this point, now here if you draw one normal, so instead of going like this straight line path, its path changes due to change in density or refractive index. When light enters from rare to denser medium, it bends towards the normal. So instead of going like this way, it bends like this direction. Again at this point you draw one normal. Instead of going like this one, again it changes their path. So in this way, at different layers of the atmosphere, it changes their path, and when it reaches, suppose observer is at this point on the Earth. When light reaches to the observer, it appears to come from this position, right now, and this one is apparent position of the object, apparent position, and this one is actual position, right? So actually the object is at this point, but when it enters through the Earth's atmosphere, its path changes, it takes curved path, like, and when it reaches to the observer, light appears to come from this point. It means the object appears at this position to this observer. It means observer is not able to see its actual position. Observer observes its apparent position. So due to atmospheric refraction, position of the object changes, right? Also, the temperature of different layers of the atmosphere also changes with time. So due to change in temperature with time, this apparent position is also not fixed. It also changes right now. So due to this, atmospheric refraction takes place and apparent position also changes with time. This is about atmospheric refraction. So you write these 2 points. First you write the definition. The refraction of light by the Earth's atmosphere is called atmospheric refraction. And why this atmospheric refraction takes place? Because the Earth's atmosphere is not uniform throughout. Its density goes on changing as you move up or down. The upper layer is rare as compared to the lower layers of Earth's atmosphere, and due to this difference in density, when light ray passes through Earth's atmosphere, they undergo refraction, and due to this atmospheric refraction, you are not able to observe the actual position of the object in the sky. You are able to observe the apparent position, and apparent position also changes with time due to change in temperature of different layers of the atmosphere with time. This is about atmospheric refraction. Now after this, I will discuss 2 important phenomena of this atmospheric refraction. First, the object appears higher than the actually they are, and also second, the twinkling of stars, and next phenomena of this atmospheric refraction is advanced sunrise and delayed sunset. So I will discuss all these phenomena one by one. First, to take a screenshot of this one fast. Now some phenomena based on atmospheric refraction. First one is the stars seem higher than they actually are, and it is due to atmospheric refraction. We already discussed before this one now what is atmospheric refraction, and you are able to observe the apparent position of the object in the sky instead of actual position. How it happens? Suppose this is the actual position of a star, and you know light ray coming from these stars. There are different light rays coming from this star, right? Now these rays, when it enters inside the Earth's atmosphere, from here different layers of the Earth's atmosphere starts, right? And this one is surface of the Earth, right? So when light from this star is coming and enters inside the Earth's atmosphere, what happens? What happens? You know, refractive index is increasing in downward direction. So it means upper layer acts as a rare medium and lower layer acts as a denser medium. So when light rays from the star enters inside the Earth's atmosphere, instead of going straight, it bends its path towards the normal, and at different layers its bending is different. It suffers multiple refraction inside the Earth's atmosphere, and instead of moving straight and reaching at this point, it reaches to this point on the Earth. And suppose observer is at this point, so when the observer observes this position of a star, the light coming, it appears that when you extend in the backward direction, it appears to come from this position, and observer is able to observe this position. This is not actual position, this is actually apparent position, and this position is only due to atmospheric refraction, atmospheric bending, right now. So when light enters from a star inside the Earth's atmosphere, it undergoes multiple refraction, bend towards the normal each time due to atmospheric refraction. At every point there it suffers multiple refraction. Then on producing final refracted ray, when the observer is near the horizon, when final refracted rays is produced in backward direction, then the apparent position is always slightly higher than its actual position. Right now you are not able to observe the actual position of the star, and you are when you observe the apparent position of it is always actually higher than the actual position of the star, and these are all due to this atmospheric refraction, right now. So after this, again this apparent position is also not constant, it changes with time, and that effect is called twinkling of stars. So please take a screenshot of this one first, then we will discuss second phenomena, twinkling of stars. Now second phenomena based on atmospheric refraction is twinkling of stars. What does it mean? You know, stars always appear at the apparent position, not at the actual position. We already discussed, it's always appear at the higher than the actual position, right? Suppose this is a position of star, and due to atmospheric refraction, observer observes this apparent position of the star. Okay, you know, but this apparent position of the star also changes with time. It is not stationary, it continuously changes. Why? Due to physical conditions of this atmosphere. Temperature varies with time. So due to change in physical conditions of the atmosphere, the apparent position of the star also changes. Sometimes star appears at this point, sometimes it appears at this point, sometimes at this point, sometimes at this point. So the apparent position of the star changes with time, and the amount of light entering the observer's eye also changes. It flickers, it is not stationary, it changes continuously, and that is called twinkling of stars. Is it okay? So you can write distant stars. First you write distant stars acts like a point source of light. This star is at very far from the Earth's atmosphere, na, Earth's surface. So this star acts like a point source of light. As the beam of star enters the Earth's atmosphere, when it enters the Earth's atmosphere, what happened? It changes their path when it reaches the observer's eye, and it suffers multiple refraction. It changes their path at every point on the Earth's atmosphere. The apparent position of stars keeps on changing. It is not stationary. First apparent position is this point, second position star appears at this point. This apparent position is not stationary. It changes continuously because physical conditions of Earth's atmosphere is not stationary, like temperature, pressure. Okay. Hence, the amount of light entering to the observer's eyes fluctuates. Fluctuates means sometimes it appears bright, and sometimes it appears dim. It means the amount of light entering the observer's eye flickers, and that effect is called twinkling of stars. Hope it's clear to all of you. What is twinkling of stars? You know, a star always appears at a position higher than the actually there. That is called apparent position, and that apparent position of the star is also not stationary due to physical conditions of the Earth's atmosphere is not stationary. It is not stationary, it changes with time. Hence, amount of light entering eye fluctuates. Fluctuates means flickers. Flickers means sometimes it appears brighter and sometimes it appears dimmer. Hence, this effect is called twinkling of stars. But only stars twinkle. Planets do not twinkle. Why? Why planets do not twinkle? The reason is simple, and it is also important, may ask in 1 or 2 marks question. Why planets do not twinkle, only stars twinkle? Actually, planet is much closer to the Earth's surface, and it is much bigger in size than the star. You can say that planet can be considered as a collection of large number of point-sized objects. So, different parts of these planets produce brighter or dimmer effect in such a way that the net effect is zero, and observer is not able to observe the twinkling effect of the planets. That's why planets do not twinkle. Reason is simple, because planet size is very much larger than the star, and different parts of these planets produce the effect bright and dimmer in such a way that the net effect is zero. That's why planets do not twinkle. Hope it's clear to all of you. Please take a screenshot of this one. Then we move to the next phenomena. Now, next phenomena of atmospheric refraction is advanced sunrise and delayed sunset. What does it mean? Advanced sunrise means the sun appears to rise above horizon 2 minutes before it actually is above the horizon. Sun is actually below the horizon, but it appears to rise 2 minutes before above the horizon, right? This is called advanced sunset, and it is also due to atmospheric refraction. I will explain you Okay, what is delayed sunset? The sun can be seen about 2 minutes after the actual sunset. Actually, the sun is at this position during sunset, but it appears to be at here 2 minutes after the actual sunset. This is called delayed sunset. Why this happen? Why there is advanced sunrise and delayed sunset? There is a 2 to 4 minutes difference between actual sunset and apparent sunset, right? Similarly, actual sunrise and apparent sunrise, there is 2 to 4 minutes difference. Why this happen? Okay, during sunrise, the sun is near the horizon, and when the light from the sun enters the earth's atmosphere, what happened? Inside the earth's atmosphere, density increases near the surface of the earth. It becomes more dense, it means density is high. So, light ray from the sun enters inside the earth's atmosphere. It bends towards the normal due to change in density from rare to denser medium, and appears to the observer that actually the sun light ray is coming from this position. So this apparent position is seen by the observer, right? Actually the sun is at this position, but the observer sees 2 minutes before the actual position. Observer seen this apparent position of the sun. That's why the sun appears to rise above 2 minutes before it actually is above the horizon. In the same way, during sunset, actual position of the sun is this one, but due to atmospheric refraction, the observer sees this apparent position of the sun. So it means the sun can be seen 2 minutes after the actual sunset. This is called delayed sunset, right? And this is also due to atmospheric refraction. So this is about advanced sunrise and delayed sunset, and both are due to atmospheric refraction. Hope it's clear to all of you. Please take a screenshot of this one. Important topic of this chapter is scattering of light. What is scattering? And students generally confused between scattering and dispersion of light. There is a large difference between these two. Dispersion is actually splitting of white light into its constituent colors, and reverse is true. In Newton's experiment, it is proved that when all these constituent colors again recombines to form white color. But in case of this scattering of light, reverse is not true, and also it is spreading of light in all possible directions by some particles present in the atmosphere, like dust particles, free water molecules. Okay, so this scattering of light is spreading of light in all directions by the dust particles, free water molecules present in the atmosphere. Actually, what happens when light rays collides with these dust particles or water molecules absorbs that light and again re-emits this light energy. So it is process of first absorption and then re-emission of light energy. This is scattering of light, and scattering takes place in all possible directions in an irregular manner, right now. So is it clear? It is a process of absorption and then re-emission of light. Suppose this is any particle, a scatterer, okay, and light collides with this scatterer, then this is incident light, okay, this is incident light. Then after colliding with this particle or a scatterer, it absorbs this incident light energy, then again re-emit this light energy in all possible directions. It spreads light energy in all possible directions. This is a scattering of light, and this scattering also depends on this size of the scatterer. If the size of the scatterer is smaller than wavelength of light or near about wavelength of light, then only this scattering is possible. But okay, this is possible only if this size of the scatterer is smaller or equal to the wavelength of light incident on this scatterer. But if size of a scatterer is larger than the wavelength of light, then what happens? Scattering is not valid. If the size of the particle is larger than the wavelength of light used, then in this case scattering is not possible. In this case, what happens? Scattering is there, but it scatters all wavelength equally. It means scattered light intensity is equally, and it again appears white. So scattering is not possible when wavelength of light used and size of the particle is greater than the wavelength of light used. Again, according to Rayleigh scattering, okay, formula is this one. Intensity is inversely proportional to lambda to the power 4, fourth power of wavelength. It means smaller wavelength, it has greater intensity. Larger wavelength, it has smaller intensity. Intensity is related to scattering, right? Scattering is inversely proportional to wavelength of light. Scattering is related to intensity. Greater intensity means greater scattering. Smaller intensity means smaller scattering. So intensity is inversely proportional to fourth power wavelength. Then also scattering is inversely proportional to wavelength of light used, right? And you know Vibgyor, wavelength increasing in this order from violet to red. So violet has minimum wavelength, red has maximum wavelength. It has lambda maximum, red color, and here violet has lambda minimum. If violet has minimum wavelength, it means scattering for violet color is most. Violet color scatters most than red color. So this one is important. Violet colors scatter most. So there are different phenomena based on this scattering of light, like blue color of the sky, okay, red color appear at the sunset or sunrise. All this happens due to this scattering of light only. There is another thing, if scattering of light takes place by collided particles. Here dust particles, free water particles present in the atmosphere. But if a scattering takes place by colloidal particles, then that effect is called Tyndall effect. It means it makes path of light visible. Suppose there are two beakers, okay? There are two beakers. In one beaker, water is present. In another beaker, you add some milk also in this water. So when light ray passes through this beaker, first in which water is kept, what happens? Here, in water, there is no small particles. All particles are mixed properly, uniform, homogeneous mixture is there. It means no scattering is possible in this case because there are no dust particles present in this water in A beaker, right? And suppose this one is B beaker. Here particles are present. That particles are called, milk. It is colloidal particles. And if colloidal particles is present, then in this case, if light ray passes through this beaker, you are able to see the path of the light. It makes the path visible, and this effect is called Tyndall effect. Here water is present in this beaker, here milk is added in this beaker. So in first beaker, no scattering takes place because it is homogeneous mixture. Size of the particle is very, very small. But in second beaker, milk is present and milk is a colloidal particle. Size of the particle is larger. So here scattering is possible and it makes the path visible. This effect is called Tyndall effect. Okay. So after this, I will discuss some phenomena based on scattering of light. First is blue color of sky. After that, red color of sun at sunrise or sunset. Please take a screenshot of this one. Okay. Now some phenomena based on scattering of light. First one is blue color of sky during daytime. Why sky appears blue during daytime? It is also due to scattering of light. How this sky appears blue? Suppose this one is Earth's atmosphere, okay, and light is coming from this sun during daytime, okay. Light is coming and in vacuum, this is free space, it traverses straight line, okay. But these are different layers of Earth's atmosphere, right? These are different layers of Earth's atmosphere. And in Earth's atmosphere, there are large number of air molecules, right now. So when the sunlight enters into this Earth atmosphere, what happens? These sunlight is scattered by the air molecules and scattered in all possible directions. You know, white light consists of all 7 colors, that is Vibgyor, violet, indigo, blue, green, yellow, orange, red, and wavelength increases in this order. It means These three have shorter wavelength, and this side yellow, orange, red has larger wavelength, and scattering is inversely proportional to wavelength of light. It means wavelength of this violet color is less than wavelength of red color. So intensity of violet, indigo and blue color is more. That's why in the sky blue color is scattered in all possible direction. Right now blue color is scattered in all possible directions. When the observer observes the scattered light in the sky, it appears blue. That's why sky appears blue during daytime. So only the scattered blue light enters our ears and sky appears blue. So these are the reason why sky appears blue. It is due to scattering of light. When light from sun traveling through this Earth's atmosphere, it gets scattered by different number of particles near the Earth's atmosphere, so it gets scattered. And you know, violet color has shorter wavelength than red color, and scattering is inversely proportional to wavelength. Na? Scattering is inversely proportional to fourth power of wavelength. Shorter the wavelength, more is the scattering. So violet, indigo and blue color has shorter wavelength. So intensity of violet, indigo and blue color is more than red color, right? That's why the scattered blue light enters our ear. Suppose observer is on the surface of Earth. Okay, and only the scattered blue color reaches our eyes and sky appears blue. This is the reason. Also, one more thing, if this Earth had no atmosphere, if the atmosphere is absent, then what happens? There is no scattering of light takes place. Scattering is only possible if atmosphere is present. Inside the atmosphere, there are large number of molecules whose size is smaller than that of wavelength of light. That's why scattering is possible. If there is no atmosphere, no scattering is possible, and hence the sky appears black. So when 1 marks question, it may ask, what happens if Earth had no atmosphere? In that case, sky appears black because there is no scattering of sunlight if atmosphere is not present. So this is the reason why sky appears blue color, and if there is no atmosphere, then the sky appears black color, right? Okay, please take a screenshot of this one. Then we move to the next topic. Now, next phenomena based on scattering of light is sun appears reddish at the time of sunset and sunrise. During sunrise and sunset, the color of the sun is red. Why? You know, during sunset or sunrise, the sun is near the horizon, right? And in that case, the sun has to travel larger distance through the Earth's atmosphere. So what happened? Blue color, violet color has minimum wavelength, so it scatters away, and only red color, which has larger wavelength, it reaches our ear. That's why the sun appears reddish during sunrise or sunset. So you have to write reasons like this one. During sunset and sunrise, sun is near horizon, right? So sun has to travel longer distance in the atmosphere because sun is near the horizon and it has to travel larger distance near the atmosphere, right? And hence most of the blue color is scattered away because blue color has shorter wavelength. Only red color, which has largest wavelength, is scattered least and enters our eyes. That's why sun appears reddish in color. Is it clear? So you have to write these points during sunset and sunrise. Sun is at which position, then which color scattered most and which color reaches our ear. Only red color reaches our ear because red color has largest wavelength. One more thing, during noon or afternoon, what happens? Sun is nearly overhead. So when sun is nearly overhead during afternoon, then the sun travels much shorter distance in atmosphere. Hence scattering is less. When the sunlight travels shorter distance, so scattering is very small amount and the sun looks white during noon time. So one more thing, this is also important why during afternoon sun is appears white in color because sun is near overhead and the sun travels much shorter distance in the atmosphere, hence scattering is less, so the sun looks white. Next, why danger signals are red in color? You know, all the danger signals are red in color. Why? Because the red color has larger wavelength, so it has to travel larger distance, so we can see red color from the very far point. That's why digest signals are always red in color, because you can write it this way: red color has largest wavelength, hence scattered less, therefore only red color can be seen from the farthest distance, and hence digest signals are red. It reaches our eyes. Okay, now one more last phenomena based on scattering of light is white color of clouds. Why cloud appears white in color? Because clouds are at much lower height. And what happens when the clouds are at much lower height? Cloud contains dust particles and water molecules which are bigger in size than the wavelength of light. And if size of the dust particles in clouds and water molecules is bigger, it means size of a scatterer is bigger than wavelength of light. And we already discussed, if size of a scatterer is larger than the wavelength of light incident, in that case Rayleigh scattering is not valid. It means it scatters all colors of incident light in same amount. Right now it scatters all colors of incident white light with same amount. It means intensity of all colors of the scattered light is same, and hence cloud appears white. So this is the reason why cloud appears white, because clouds are at much lower height and the dust particles and water molecules in the clouds are very bigger in size than the wavelength of light used, and here Rayleigh scattering is not valid. So it scatters all colors of incident light with the same amount, hence intensity of all scattered colors of all the colors of the light is same, and hence cloud appears white. So these are different phenomena based on scattering of light. Hope it's clear to all of you. Please take a screenshot of this one. So with this, I am going to end one short revision of chapter Human Eye and Colorful World. Hope you like this one short revision of this chapter. If you want one short series of other chapters also, you must write in the comment box so that I will make videos for other chapters also. Up to then students, keep revising and stay tuned with this channel. Thank you.